Hello and welcome to our presentation on DC and inductors. Direct current is a constant flow of electrons that travel in one direction only. It typically flows from a high density region of electrons to a low density region of electrons. The main advantages of direct current are its ability to easily be stored rather than alternating current, the fact most electrical equipment works better with direct current, and overall has better compatibility with renewable resources like solar and wind. The main disadvantages of direct current are its limited range and the fact voltage cannot easily be stepped up or stepped down. A simple DC circuit is as follows. Here you can see the limited range of direct current. An inductor is an electrical component that consists of a coil of wire wrapped around a core. The simple use of these components is to store electrical energy in the form of magnetic fields. Inductors are reliant on Faraday's law and Lenz's law. Faraday's law states the size of an induced EMF is proportional to the rate of change of magnetic flux, while Lenz's law states the induced voltage in a coil opposes the voltage source that led to the establishment of flux. Inductors are used in many electronic applications including sensors, transformers, motors, and energy storage. Inductors have four main types seen here as air core, ferromagnetic core, tapped, and variable. Inductance is a terminology used to measure the strength of a magnetic field induced around a coil from an induced current. The higher the inductance, the higher the strength of the magnetic field. Inductance measured in henries is equal to the permeability of the core times the number of turns in the coil squared times the area all divided by the length of the coil. Inductors act similarly to resistors and are added the same way in series and in parallel. Charging inductors are similar to capacitors. The time constant is given by tau, which is equal to inductance divided by resistance. The transient will end after a period of 5 time constants and will then be in steady state. Inductor current. IL equals voltage divided by resistance times 1 minus e to the negative t on tau. When t equals 0, IL equals 0, and therefore the inductor will function as an open circuit. Inductor voltage. VL is equal to voltage times e to the negative t on tau. When t equals 0, VL will equal E, and therefore the inductor functions as a short circuit. An example. In the following circuit, if the switch is closed at t equals 0, determine the time constant and the mathematical representations for inductor voltage and current. Then graph VL and IL over 5 time constants. The time constant is equal to 200 millihenries divided by 10 ohms, which is equal to 20 milliseconds. With this, we can then determine inductor voltage and current. These equations produce the graph seen here as explained previously. Thanks for watching, and I hope you learned something.